Hello. This section we are continuing to look at sketching graphs, and last time we looked at cubic graphs, so x cubed and so on. We're actually going to go one step up in this section, and now we're going to look at something called quartic graphs. Now, a quartic is, well, it's going to be x to the 4, okay? So it's going to be, for example, this expression x to the 4 plus 2x cubed minus x plus 6, something like that. But we have an x to the 4 term, okay? Which means it's a quartic, okay? So obviously, in that case, the general expression of a quartic is ax to the 4 plus bx cubed plus cx squared plus dx plus e. So there's a lot of stuff going on there. Okay, but that's the general quartic. The whole idea is we have an x to the 4 term, okay, which will give us our quartic. Anyway, so we're going to look at sketching this. So basically, it's sort of the same idea when we looked at cubics, when we, in particular, we did analyze the type of roots. So remember that when we had a what we called a single root, when it's just the bracket or the factor on its own, um, it just passes through the axis, right? So it look like that, okay? So if that's x equal to a, it just passes through the axis, okay, no problem. But then when we had a double root or a repeated root, so when we had the factor squared, so remember when we could factorize it into brackets, into factors, if it's a squared factor, that means instead it touches the axis, okay? So it would look like that. So in that case, it touches the axis, right? So it doesn't go through the axis, it just touches it, okay? So if I write that there, passes through axis, cool. And then when we add a factor cubed, so that'd be a triple root in that case, or triple repeated root technically. In that case, it actually forms it's something called a point of inflection. So it looks like the x cubed graph, right? So we go up, but then eventually, instead of just passing through it, it kind of levels off at that point, and then when you go back up, then it starts to level, and then it starts to go back up again. So it looks like the x cubed graph, right? So the point would be there in the middle there somewhere. But that is called a triple route, where instead of just passing through it and not changing course particularly, it starts to level off at the point. Okay, so that'd be a triple route, and we call that particularly a point of inflection. Okay, when it looks like that. Cool. So that's the main idea again with this section is actually we can factorize the roots, okay, of x to the 4 and so on into we get the roots we can factorize, and we can look at the roots and the factors, and it will form the pretty much the same idea, right? Of whether it passes through the axis, whether it'll touch the axis, or whether it'll form a point of inflection where it starts to level off around that point. Okay, okay, well that's gonna be the same idea we're gonna use. What about Quartics specifically? So, if we have, so it forms two shapes, and again, like we did with cubes and quadratics, with Quartics, remember it has a positive shape like that if the coefficient ax cubed, if a was positive, and a negative shape, so it went downwards if with ax cubed when a is negative, okay? Remember that? We're going to use that exact same idea with quartics, okay? And again, and quadratics. And we're going to look at the sign of the x to the 4 term. Now, when it's x, so when we have ax to the 4, when a is positive, it forms a sort of W shape. So it's going to go like that. Like that sort of shape, right? And to keep into note, that's going to be usually three turning points, okay, which is there, and there. So that'd be sort of a W shape, almost like two quadratic curves together, right? Like that, right? Two U shapes. And obviously, we know a U shape is a positive quadratic. Remember, a smiley shape. Um, but that's the positive. But then on the negative, it forms an M shape, so it kind of flips around again. So instead of if you have ax to the 4 when a is negative, so for example, we had like minus x to the 4, so a negative. Obviously, it's an M shape, so it's going to instead look like that, okay? Some of it like that. And again, that'd be three turning point. Oh, that's not a turning point. Um, so an M shape with turning points again, there, and there. And yeah, so that's the same shit. That's basically it, right? So it's pretty similar to what we looked at last time with called cubics. So we're going to first look at the sign of the x to the 4 term to see what type of shape. Is it going to be a W or an M shape? Um, and then we're going to look at the roots to determine what the root will look like using what we just discussed up here. Okay. Also, relating to these graphs, and the textbook does talk about this. I thought I'd go over it. But we can also consider the what we call the long. Oh, that's not very long. Long-term behavior of these graphs, right? Uh, that is supposed to be behavior, isn't it? Who cares? It's maths, not English. Anyway, long-term behavior. So that is if we plot, say, this graph here, right? This generic positive cubic, quartic, sorry. That perhaps look like this, right? The long-term behavior, obviously, that's the x-axis and the y-axis. It's what happens for long or values of x. So what happens to the graph as x gets larger and larger? Basically, when x tends to infinity, okay? And what you'd spot is actually when x goes to infinity that way, the graph, if you were to continue this on, also shoots up to infinity. Okay, that is because x to the 4, right? Because it's a positive. It doesn't matter what is in front of it. It's just a number. We only care about what happens to x to the 4 specifically, because x to the 4 is the highest power. So the way the graph increases overall for the long term only depends on x to the 4. So x to the 4 then, if x is a really big number, x to the 4 and a positive number, x to the 4 is also going to be a really, really big positive number, right? So that means the graph well, x to the 4 will also go to infinity, which is why when you have a positive quartic graph, it will go up to infinity that way. Um, on the flip side, if you have the negative version, which looks like this, remember here, as we just discussed, when x goes to infinity, in this case, when x goes to that way, if we continue down here, actually it's going to be minus x to the 4 because it's the negative, right? Ax to the 4 is going to be a negative amounts of x to the 4, okay? Now, if we have x to the 4, as we discussed, that's also going to infinity. It's going to a really big number. But then if we negate that, well, the negative of a really big number is a negative big number, right? So it's going to go to the left. It's going to go downwards to negative infinity, okay? So instead of going upwards, in this case, it's going to go downwards to negative infinity, okay? So that's the long-term behavior. Also, it doesn't have to just be the right side. We also consider the left side as well, because obviously the graph goes on the left side as well. So that's when x goes to negative infinity. So it goes the other way to the negative. In that case, when we have x that goes to negative infinity, x to the 4, well, actually think about it. If x to the 4 is times an x by itself 4 times. So if we have a negative number, if you times a negative number 4 times, that's going to be positive, isn't it? Negative times negative is a positive. So then two positives is a positive. So x to the 4 will be a positive number. So the interesting thing we get here is despite x being going to a really large negative, right, which is negative infinity, we can call it. X to the fourth still also goes to positive infinity, so it still goes upwards, and we can see that here in the graph, right? When x goes to the left to negative infinity, the graph still shoots up to positive infinity. It's on the positive y-axis, right? It's going upwards. Because of the fact that when you square because remember x to the 4 is just x squared squared. So ultimately it's to do with the fact we have a square number. And we know if you square a negative, it would be a positive. So that's the reason for that. On the flip side, on the negative version, the negative graph, when x goes to negative infinity, so when it goes to the left here to negative infinity, the graph minus x to the 4 will still go to minus infinity because x to the 4, as we discussed, that here will be infinity. So we have a negative infinity with negative infinity, right? So you can see that here on the graph here again, because when x goes to the left, would go to negative infinity, right? The graph shoots downwards, so it's going to negative infinity as well. Okay, so that's you will see we will go over that as the course goes on when we look at other types of graphs and other types of functions. The idea of long-term behavior we will go over again, and it does come up in exams, but that's just a sort of explanation behind the graphs. Okay, cool. So let's actually jump into some graph sketching. Okay, so it's basically the same idea as with cubics, right? By analysing the roots. So part A, we have y is x plus 1, lots of x plus 2, lots of x minus 1, x minus 2. Okay. So first of all, again, we need to determine what type of quartic. Is it going to be a positive like this, or is it going to be a negative like this? It's going to go downwards if it's negative, or is it going upwards when it's positive? Okay, well, rather than do that, just analyze what the x to the 4 power is, x to the 4 coefficient, right? How is x to the 4? Is it positive or negative? Well, how are we going to get x to the 4 from these brackets? Do not expand it. There's a lot of brackets. Do not expand it all. You can quickly work that out by just realizing we can just times the x terms in all the brackets. So x times x is x squared. Then another x is x cubed. Then we have x another x which is x to the 4. So we have one x to the 4, which is positive, right? So that means we're going to get a positive shape. So it's going to look like this, okay? So a sort of W shape. Cool. Okay, now let's actually go on to sketching it. So draw our axis, x and y. Then we need the y-axis, right? The y-intercept firstly. That's again if you set x to 0. So when x is 0, the y becomes, and then set 0 to let's set 0 to x in each bracket. So we get 0 plus 1, it's going to be 1, then 2, then minus 1, then minus 2. That's going to get me, what's it going to get me? Well, that'd be positive 2, that'd be minus 2 afterwards, that'd be plus 4. Okay. Cool. Okay, I'm going to get rid of that now because I'm going to need room for the next question after. But yeah, y should be 4 if you just plug in 0 there. Okay. Cool. Okay, so we can plot that then. So 4 is probably going to be about there. Lastly, we need to put the roots on. So when it crosses the x-axis, that so the roots of the again when you set the whole thing equals 0 because y would be 0 if it's on the x-axis. So you're going to set each bracket, each factor to 0. So firstly, you would have x minus 1, right? Then you would have x minus 2. So you have minus 1 here, minus 2 there. Then we're going to have plus 1 for the next one. Then we're going to have plus 2 for the last one. So those are full roots. And then we need to study what type of roots we have by looking at the power or how many of each bracket we've got, right? And then we're going to use these three cases here that we talked about. So let's have a look at our roots. Are any of them repeated then? Actually, no, they're all singular. They're only a brackets that appear once. There's no like squared, there's no cubes going on. It's just all singular. that means it's simply just going to cross through all the points, okay? So therefore our shape, our quartic with this shape in mind is going to look okay. So then the graph would look a bit like this, right? So it crosses through these two routes, and then it goes reaches the y the y intercept, and then it goes through the other two routes. Okay, and interestingly, it is actually this particular graph is symmetrical about the y-axis, right? Because of the fact the two routes either side of the axis are evenly spaced, right? -2, -1, and 1, 2. So yeah, um, so symmetrical meaning the graph looks the same on either side of the y-axis. Okay, cool. So that's first one. Then we're going to look at this one. Y is x of x plus 2 squared at 3 minus x. Okay. So firstly, again, we need to determine what type of shape is it. Is it going to be a positive going up or going down? Is it going to be a W-ish shape or an M-ish shape? Okay, well then we need to work out what the x to the 4 is, the quartic power. So, okay, well, to do that, we're going to need to times all the x's in each bracket together, right? But if I do that, I get x cubed. But I realise that this is squared, so I could say this is x of x plus 2. X plus 2 again, it repeats itself, 3 minus x. So then it should be a lot easier and clearer to see what the x to the fourth power is. So it's going to be x times x times x times minus x. That'd be minus x to the 4, right? So that's going to be a negative one. So it's going to look have this sort of shape. Okay. So it's going to go down. Okay. So deduce the shape. So let's draw our axis. So we have x and y. Okay. Then we need to we'll find the y-intercept first. So that's when x is 0. If you substitute x is 0, well, if you get x is 0, this x at the front is going to be 0. So you multiply everything by 0. So ultimately, that means it's just going to pass through the origin. Okay, so that'll be the y-intercept at 0. Okay, lastly, we need to locate the roots. So that's when you set each part of this equal to 0, because y would equal 0. So, well, firstly, x will be 0, but that's just the origin. Then we have x plus 2 equals 0, so that'd be x minus 2 there. Then we're going to have, lastly, 3 minus x equals 0. That'll mean x is 3. Okay, the ordering's a bit weird because it's not x in the front. This time it's at the right side of this. But if we are struggling, you just set 3 minus x equals 0, and then you can explicitly solve from there to get x equals 3. Okay, so the last root's going to be at 3. Cool. Lastly then, well, we've got the roots, but what type of roots are there? So let's look at the brackets here. So x is the at 0, that's just singular. It's just x, not a power of x. So it will just simply cross through it. Then we have x plus 2 squared. So because that's a double repeated root, isn't it? It's two lots of it. Okay, it repeats itself twice because it's a squared. So it's the bracket squared, meaning it's gonna form it's gonna touch it, right? So it's gonna be like that. It's just gonna simply touch at this point. It's not gonna go through the axis. Okay, and lastly, this last one at 3, right? X is 3. That's a singular fact. That's a single bracket, so that will be a could just go through it. Okay, it's a single root. Okay, with that all that in mind, well then, firstly, it touches at -2, so and it's going to go as an M shape here, right? So first, it's going to do this, touch it, then it's going to go back down, then it's going to cross through the axis. Oh, hang on a second. So touch it there. That's not the best drawing, is it? So it'll look a bit like that, okay? And there we are. Cool. Uh, so there we are. Lovely. Okay, so that's part B. Now part C, we have x minus 1 squared. x minus 3 squared. Okay, cool. Okay, so then firstly we need to determine if it's a positive or negative shape. Well, again, we're going to look at the powers of x in each bracket. Well, these are both squared. What I realise is if I square this, it's just going to be x times x, right? So it'd be x squared from this bracket. Likewise, we're going to get x squared here because if we repeated the bracket again, x times x would be x squared, okay? So x squared times x squared would be x to the 4, okay? And that's what we get. That's the power of x to the 4. Coefficient of positive 1, positive, so it's going to have a W sort of shape. It's going to go up, okay, as x gets bigger. So it has a W shape. So, okay, let's draw our axis. Okay, then we need to locate, well, the y-axis first. Well, the y-axis again occurs when x is 0. So the y, when x is 0, if you substitute x as 0, you're going to get minus 1 squared and then minus 3 squared. If you put that in a calculator, you should get 9, positive 9. So it's going to go up there somewhere. Okay, cool. Okay, lastly we need to find the roots. Well, that's when each bracket equals 0. So firstly x would be 1. Then x minus 3 would be 0. So x would be 3. Okay. So there we are. So we've got our two roots. Lastly, what type of roots? Well, they're both squared brackets. So they're both are double repeated roots. Okay. So they're both going to just touch it at the axis at that point. So with that in mind, and it has this sort of shape, let's sort of draw what we're going to get. So it's going to start up here maybe. So then it's going to touch it. It's going to come back down. It's going to touch at 3. Then it's going to shoot back up. Cool. So that'll be the graph there. Lovely. Um, There we are. Okay, let's have a look at some more exercises then. So you see the main idea, right? It's the idea of, I think the probably hardest bit is trying to, again, deal with the roots of it and what the roots look like by looking at how if they're repeated or not. But, okay, cool. So question 1, so I want to do some more graph sketching to really practice. So we have y is x of x plus 1 squared x plus 2. Again, by the way, these were questions picked from the exercise book for this exercise. I picked a more interesting and the different types of graphs, so they're not necessarily ABC, they're CIJ, but I think they're the more interesting questions I picked out that are a bit different. Anyway, so what we do for again, what type of uh, Quartic is it? Is going to be a positive one or a negative one? Well, look at x to the 4. Well, that's going to be x, but x to the 4 power, what coefficient? So we're going to have x here, and then we have an x plus 1 squared. That's going to get x squared if we expand that. So x times x squared will be x cubed, times by x will be x to the 4. So again, it's just positive 1, so it's going to have a W shape, as the coefficient of the x to the 4 is positive 1. Okay, cool. So to draw our axis. There we are. Cool. Then we need, well, let's do y-intercept first. So if you substitute x is 0 in, uh, y would be, well, it'd be 0, wouldn't it? Because x is there's an x. So you times everything by 0. If you plug x as 0 in, you get 0. So it's going to pass through the origin there. Okay, well then that's where we need the root. So the first root is going to be 0, obviously because x is 0. Then the next part is x plus 1. If that's 0, then x is minus 1. Okay. Then lastly, this bracket, well, x plus 2 equals 0, so x would be minus 2. There we are. So those are three roots. Now lastly, what type of roots? Well, x and x plus 2 are singular because they're just single brackets, but this is a double bracket because there's a squared there. So times it by itself twice. So it's a double repeated root. So it's going to touch it at minus 1. But at minus 2 and 0, it's just going to go through it. So with that in mind, and it looks like this shape again, again, it's going to be like this. So it's going to touch it there. And there we are. Cool. There we are. And then let's do the next question. part I. So now we have minus of 2x minus 1 square, cubed, sorry, x plus 5. Okay, so that'd be y equals, by the way, minus, there we are. So, firstly, again, what type of quartic? Well, we need the x to the 4 term, so we have 2x here, so that'd be the x term. Now, this is cubed, so we're going to be times in 2x 3 times. But 2x all cubed, that's going to be, well, 8x cubed. Well, it's just positive, right? It's 8x cubed, right? But it's positive, that's what we care about. But then that'd be times by x, so that'd be 8x to the 4, okay? That's our power. However, we have a minus at the front of all this, so ultimately this will be minus 8, like x to the 4, okay? That means it's a negative, so it's going to have an M shape. It's going to go downwards, okay? Okay, well, then that's all our axis, as usual, and then we need our y-intercept. Well, y-intercept is going to be when x is 0. Well, if we plug in x is 0 into this y expression, y would be minus of 2x would be 0, so you'd have to be minus 1 cubed. 0 plus 5 would be just 5. Put that in your calculator, you should get positive 5. Okay, cool. So it's going to go through there probably, somewhere there. Pass through the y-axis. That's 5. Lastly, we need the roots. That's when each bracket equals 0. So 2x minus 1 equals 0, which means x would actually be a half. Okay, so let's say it's about there of a half. Okay, cool. And the other root, the other bracket would be x plus 5 equals 0, so x would be minus 5. So actually, it'd probably be about there somewhere. Okay. Lastly, what type of roots are we dealing with? So we labelled it all, but we need to know what type of roots to look for. So this is a triple bracket. So it's going to actually be a point of inflection, which looks like x cubed, remember? So it's going to go and level off at a half. Then it's going to slowly climb back up again like that. So that's what that's going to look like. And then the minus 5, that'd be minus 5, it's just going to pass through it because that's a singular bracket. So with all that in mind then, and it has to look like this M shape. Okay, well, because of the distance, so it's going to probably look like that. Then it's, oh, no, 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 not a line. Probably like that. Then it's going to, oh, not like that, sorry. Try again there, turning point there, it's going to go down there. But then I want a point of inflection, so it's going to start to level off at that point. And there we are. That's what it's going to look like. There we are. So that will be the quartic there. Okay. So hopefully see at that point, it kind of looks like a point of inflection. It looks like a water slide in a way. So it's steep and then it levels off. And then it starts to level off again after it reaches a half. But yeah, so there we are. Cool. Um, there we are. And then the last part, part J, we have x plus 4 to the fourth. Now, this is the fourth power. Well, we haven't actually looked at that. We looked at powers of 1, 2, and 3 when they're single, double, and triple. What about with their quadruple in this case? Well, firstly, again, let's look at the information we normally look for. So, firstly, what type of shape? Well, it's x here, and it's going to be times by itself 4 times, right? You're timesing the same thing 4 times. You're just going to get x to the 4 in the end. So again, that would be a positive shape like that. Okay, well then, if we draw our axis, and then let's find our y-intercept. Firstly, so that's when x is 0. Y would be 4 to the 4, right? If we sub in x is 0 in here, but 4 to the 4 is going to be, oh, it's going to be 256. So let's don't do a massively long y-axis. We'll just leave it there, 256. Okay, but then what's the root of x? It's going to be if you set the bracket equal to 0, while x plus 4 because there's so x will be minus 4. So if 2, 5, 6 is there, minus 4 probably is going to be like there or something in it. To scale roughly, but there we are. Um, okay. So we draw a root. So now we need to look at what type of root it's dealing with. This is to the fourth power. Now, what's interesting is that when it's to the power of 4, again, it actually kind of looks like a double root. It kind of touches it, and that's what happens. And in general, I should say, by the way, when you have x to the 4 like this, which again is a quadruple root, right? It's x repeated 4 times. It looks like this. So it's like, as I said, it is it kind of touches it, but it touches it like this. It kind of levels off as well, but it touches it, so it looks a bit like that. Um, but basically, it looks like x squared graph in a way. Actually, no, it looks a bit so it's a bit more sudden with a drop. There we are. There we are. So it looks a bit like that. So it's slightly more like elongated. It's not like x to the x squared where it's like that. It's a slightly more like stretched out. I don't know. But the whole point is it basically like what's it called? It still touches it as 0, right? Ultimately, but it's just a little bit more stretched out, a bit more elongated. But it's still the main idea is when you have a fourth power, a quadruple repeated root, repeated 4 times the bracket. It again kind of touches it, but it's just ever so it's slightly. I don't know. Hopefully, you can notice the difference, but it's slightly more like elongated and drawn out when it touches it. But yeah, there we are. So that's x to the 4. Well, then x plus 4 is going to be exactly the same thing. It's going to then have that same sort of shape. It's going to go down like this. It's going to touch it like this, and then it's going to shoot back up like that. Okay, there we are. So it's going to look like that sort of graph. Okay, and actually, it doesn't really have a W shape at this time. But but it still is that sort of shape. Okay, it's still the idea is that it's going up. Okay, but yeah, cool. Uh, there we are. Let's have a look at this example. So what we can do now is like with quadratics and cubics, some questions might ask you to actually go backwards. And when you're given a graph of a quartic, they might ask you to work out the original equation, the equation that represents that quartic. Using this information, basically in this case, it wants you to work out these missing coefficients, like B, C, D, and E. Okay, so part A is saying find the coordinates of P. Now P is P is what? It's a y-intercept, right? So when x is 0, so it'd be 0 y, right? We don't know what y is, the y coordinate, but we can work that out because when something x is 0, right? If we get x is 0, y would be, well, x to the 4 cubed, squared, and x all go away because they'll all be 0. We're left with e, this number e, but we don't know what e is at the moment. Okay, so actually we can't work that out just yet. Actually, so we're going to leave that there then. So because then we probably need to work out what e is. Well, we need to know what e is, but we're going to need to work out what the quartic is, right? So we're going to have to again look at the graph, look at the points we're given on the graph, and then use it to work it out. Anyway, so what points are we given? Well, it tells us when it passes through the x-axis, so it tells us the roots, all 4 of them, right? -2, -1, 2, and 3. So we have x equals -2, -1, 2, and 3 are the roots, okay? Now remember, we can work backwards and put these as factors. So if these are the roots, then we can have x plus 2, x plus 1, x minus 2, x minus 3. Okay, and that'd be equal to 0 because then if we were to solve these roots, you would get these factors. You'd get these roots. Okay, remember. So yeah. However, what do we need to also account for when we're going in this when we're doing it this way, we need to account for the fact there could be a coefficient as well at the end. Because remember, with an equation, say if we have ax equal to 0, right? 0, that's still saying x is 0 because we can divide by a and it'd be the exact same thing. However, we need to account for the fact there could be a constant a, okay, before we divide it through by it. So because we're going backwards to work at the equation, right, we need to account for the fact there could be an a there. Okay. Cool. Okay, well, we need to work out what this a is. So we need another point. Uh, which we don't have. We have P, but P is what we're working out, so that's not going to help us. These are the only 4 points we know. Okay, so maybe let's look at the question again. Well, notice this. This conveniently, they just told us is x to the 4. The coefficient of x to the 4 is 1. They told us that actually. So we just need to work out the other coefficients, but we can use it to help us. Why? Because if we were to expand all these brackets again, but and remember, like when we sketched it earlier, to work out the x to the 4 coord, the x to the 4 coefficients to determine whether the shape was positive or negative. We've worked out the x to the 4 coefficient by timesing all the x's in each bracket. If you times all the x's, right, you get x to the 4, right, and then you'd have then times it by the a outside the number a. Okay, so ax to the 4 is what we would get, right, as the x to the 4 term. But the total is x to the 4, right? The coefficient is 1. So, therefore, ax to the 4 is just equal to x to the 4 because the totals in the question have the y, for the quartic equation, the x to the 4 power is just 1, right? It's just a coefficient of 1. So if we match the coefficient, a just simply equals 1. So in this actually surprisingly particular case, we didn't. Well, we did need to account for a missing coefficient. We needed to account for a missing factor a missing number coefficient a. Because obviously again when you're solving equal to 0, um, you could just divide through by cancel out the what's it called, the coefficient, right, because of the fact of how we solve equations. But in this case, a just turned out to be 1 anyway, so it doesn't really do anything. But we did need to, it was vitally important, we did need to check that actually the coefficient was 1. Okay, so a is 1, we can sub that in. Well, we don't really need to sub it in because it'd just be 1 outside. So that'd be just itself. Anyway, then that means our quartic would be simply x plus 2, x plus 1, x minus 2, and x minus 3. Then we just need to expand it all out to get a quartic like this, okay, in this form. Okay, okay, this is going to be a bit arduous, but let's do it. Firstly, again, let's just expand, let's say, these first two brackets, so that would be x squared plus x plus 2x plus 3x plus 2. Then we have x minus 2, x minus 3. Then let's expand this bracket with that one. So that'll be, well, x squared times x will be x cubed minus 2x squared, then with the 3x times x is 3 plus 3x squared. Then we have 3x times minus 2 will be minus 6x. Then lastly, with the 2, we have 2 times x is 2x. Then 2 times minus 2 is minus 4. With the other bracket minus 3. We can simplify it to make it a lot easier for us. So simplify this bracket because we can collect some terms. So we'll have x cubed, then minus 2x squared plus 3x squared will be plus x squared. Minus 6x have 2x be minus 4x, minus 4, lots of x and minus 3. Then we need to expand this again. So firstly, x cubed times x be x to the 4 minus 3x cubed. Then we do the x squared part, x squared times x be plus x cubed. Times minus 3 be minus 3x squared. Then next minus 4x times x be minus 4x squared. Minus 4x times minus 3 be plus 12x. Then lastly, minus 4 times x be minus 4x. And minus 4 times minus 3 be plus 12. So that's it, right? So then finally we can simplify it to get x to the 4, then minus 3x cubed plus x cubed and minus 2x cubed, squared, cubed, yep. Then minus 3x squared minus 4x squared and minus 7x squared. Then we can collect the x terms here, plus 12x minus 4x will be plus 8x. Then lastly, the number at the end will be plus 12, and there we are. That's our quartic. So therefore, it said to find the values. We can do part B. Find the values of B, C, D, and E. Well, if you just read off, those are the coefficients, right? So therefore, B would be minus 2, C would be minus 7, D would be 8. Oh, and E would be 12. Now, E is useful. We know what E is now because that's what we need to find in part A, remember? If Y was E, therefore Y is now 12, remember? Because now we worked that out. So therefore that's a coordinate, right? P is the coordinate 0, Y. So P is 0, 12. And that's the y-intercept. There we are. Cool. Okay. Final question then. It's a challenge question, but it's perfectly doable. Pretty similar to what we just did. So we got the graph again of a quartic like this. They need to find all the missing values again. So again, firstly, let's consider what we're given. And we're given this point, the y-intercept, and actually the two roots as well. Now, there are only two roots, which is interesting. But what are the roots? Well, we have x is minus 1 and x is 3 are the roots, right? So that means the factors we can write as x plus 1 and x minus 3. Now, there's only two roots, but I kind of need it to be x to the 4. If I expanded this, I get x squared, right? That's not really enough. But then I have to study the type of roots we've got, right? And I notice they both touch the axis at those points. Remember when they touch, it's a double repeated root, okay? So they're both going to be squared. There we are. And that will equal 0, okay? So therefore that would then give us an x to the 4, so we know we're good there. So that all makes sense. Then lastly, again, because we were solving and we're going backwards to get the quadratic, we need to account for also a numerical factor, okay, a multiple as well, a multiple a. Okay, remember that will give us ax to the 4 term, which is what we need there, right? Anyway, so with that in mind, then, well, can we work at A then? Before we expand, well, we have another value. We have another point. This y-intercept is at 3, so it's 0, 3 is a point we know. So, which is what I circled, right? So if we substitute that point in, so but what this will be y, right? So the y is 3. That means 3. Uh, 3 equals this whole quartic I've got here, which is a lots of x plus 1, well 0 plus 1 will be 1 squared, and then 0 minus 3 will be minus 3 squared. So if I expand out, I'm going to get, if I do that in a calculator, 1 squared times minus 3 squared would be positive 9, so 9a equals 3. Therefore, a is 3 over 9, which is a third. Okay. Cool. Okay, if I substitute that in then, I then get y is a third of x plus 1 squared, but that'd be x plus 1 repeated, right? And likewise, x minus 3 squared is x minus 3 times by itself, which then allows me to easily expand the brackets and see what I'm doing. So I have a third of x plus 1 firstly. Let's deal with these double brackets, which should be x squared plus x would be plus 2x, plus 1 times 1 would be 1. Then I have x minus 3, x minus 3. Then I'm going to deal with this bracket and the x minus 3 bracket. So that'd be a third of firstly x squared. So x squared times x is x cubed. Then x squared times minus 3 being minus 3x squared. Then I deal with the 2x term here. So 2x times x would be plus 2x squared. Then 2x times minus 3 would be minus 6x. Then I have plus 1 here. 1 times x is plus x. And then 1 times minus 3 would be minus 3. And then the last factor, x minus 3 at the end. Then I'm going to expand these two, but I'm going to simplify first, right, to help me out. So I have a third of x cubed minus x squared. If I collect all the like terms together, right, simplify, minus 5x, minus 3. Okay, cool. Then that's x minus 3. Okay, I need to make more room. So, okay, then I need to expand this. So that'd be a third of, well, x cubed firstly. X cubed times x would be x to the 4. X cubed times minus 3 would be minus 3x cubed. Then the next term minus x squared times x would be minus x cubed. Minus x squared times minus 3 would be plus 3x squared. Then the next part minus 5x times x would be minus 5x squared. Then minus 5x times minus 3 would be plus 15x. Then lastly, we have minus 3 times x minus 3x. Then minus 3 times minus 3 would be plus 9. Okay, so let's simplify. So we have a third. So let's collect all the terms together, and that's x to the 4 here. There we are. So that's x to the 4 minus 3x cubed minus x cubed minus 4x cubed plus 3x squared minus 5x squared would be minus 2x squared. Then plus 15x minus 3x would be plus 12x plus 9, and there we are. So lastly then we can times out by a third, right time expand with the third here, to then lastly get a third x to the 4 minus 4 over 3 x cubed minus 2 over 3 x squared plus 12 over 3, but actually we can simplify that because 12 over 3 is 4, right? So 4x plus 9 over 3, which again, that goes to just 3. And there we are, and that's equal to y, right? Our curve, right? Our expression. So there we are. So then the values the coefficients a, b, c, d, e, if we read off, simply a is going to be a third, b is going to be minus 4 over 3, c is going to be minus 2 thirds, d is a 4, right, over there, and e is the number at the end, which is 3, okay? So just comparing with all the coefficients there, and there. There we are. Cool. So yeah, that's Quartics. So cool.